It is my pleasure to introduce today Ben Lowen. Most of you know him, but for those of you who don't know him, he's a PhD student in my lab. Ben did his bachelor's at the University of British Columbia. He did a dual major in biology and oceanography. He then went on to the University of Southampton, where he did a master's in oceanography. And then he went back to the other coast, back to this continent again, and he went and did, he started his PhD in oceanography at the University of Alaska Fairbanks, and then transferred here in 2022, where he has been working as a research assistant. Since he's been here, Ben has already published 2 papers, and he has a third one in review. And he is our local expert on the RV Savannah new flow-through system, which is an NSF project that was funded a couple years ago. And he's also become our local expert on Coriolix, which is what we'll be hearing about now, which is the way in which we interact with that flow-through system. And I hope you all enjoy it. If you have questions, this is going to be a very interactive kind of presentation. So if you have questions along the way, or if you want to be more interactive, please do so. Ben will love that. Without further ado, all yours.
Wonderful. Thank you for a wonderful introduction, Sarah. One moment while I get the lapel mic sorted. Okay, so as Sarah said, I'm aiming to make this interactive. So if you have questions, thoughts as we're going along, please feel free to chime in. There are also going to be a handful of questions scattered throughout here for interaction. Please engage with them. I hope that this helps everyone not fall asleep and feel like they're learning the material. So without further ado, Coriolix. What is Coriolix? Well, cruise observation, real-time interface, open, live information exchange. Yeah, that's a long one. So Coriolix. Brief outline, intro, and then I'll walk you through it so you're familiar with it, planned updates, and then some Q&A at the end. So what is Coriolix? At its base, Coriolix is an information exchange system. It's basically a website where you can go to look at the data that's coming off the ship. And it's user accessible, meaning you can get it on the ship or on shore at the same time. And it does all the processing for you. It makes it so that you can pull up real data right as it comes off of the instruments. You don't have to download it, run a script, and then figure out what's going on. It's just going to graph it for you. And then lastly, of course, it maintains logs for the instrument calibrations, maintenance, and provides technical information to make your lives easier when you're at sea. So you don't have to go through a bunch of different manuals and find out, what was the string this is supposed to produce? So next question you might have is, who's behind Coriolix? So the folks behind Coriolix are over at Oregon State, and this has been an NSF-funded / NOAA-funded project where they've put this together in order to make different ships, and I'll go over those in a minute, easier to access on shore and on sea. And it aims to help you as scientists get the most out of the data that is available on the ship and be able to make great decisions as you're at sea. So why am I presenting this? Sarah gave a fantastic introduction. Essentially, I'm using Coriolix to get all of my data. So Coriolix allows me to use the RV Savannah as a ship of constantly. When out, it's constantly collecting its flow-through system data. And this provides the... Jay, could you mute yourself, please? Background for my data stream. Then the other part is Sarah's grant. Sarah's grant is the reason we're able to have Coriolix on the ship. As part of the biome project, which got the cool instrument, she wanted to be able to make sure it was accessible to everyone who wanted to use it. And Coriolix was the solution to that challenge. So why use Coriolix? Well, it really depends on you. Your research comes in different flavors. And I'm here to tell you some of the things it can do. And you might come up with cool new ideas, or you might already have existing ideas of how to do your research. So take the cool things that you like and use them. And hopefully Coriolix becomes one of those things. So where can Coriolix be found? Well, previously Coriolix was on the RV Endeavour and the Point Sur. It's currently on the RV Savannah and on the RV Coriolix, and it's planned to be on every NOAA ship going forward, though implementation of that is slow in progress, but happening. So hopefully what you'll learn here will be useful to you in the future. So before your cruise, what can you do? And these are overview. I'll go into more detail in a minute. You can use it to plan your cruise. You can pick your stations, figure out how far apart they are. You can use it to determine the instruments you're going to be using, what they're going to give you, what's going to be instantly processed so you can get at it if you want to make on-ship decisions about where to sample. And you can invite collaborators so that they can assist you. Then during the cruise, you're going to get live processed data, you're going to have access to satellite, you can set alerts for when conditions change. So say you're trying to find the Gulf Stream. You want to know when you go from that high temperature salinity Gulf Stream water to slightly cooler water. And we plan to use this to enable you to go from being able to see part of the sea around you to the entire picture, granting you essentially a bird's eye view. And then lastly, after your cruise, I'm sure you've all been here, you're trying to get the data. An hour goes by and you're ready to move on. Maybe the PI has it. Well, we want to make it so that you can just sit there and be done with it. Hopefully one click, but this will be a caveat. Most can do it in one click if you really want to. All right, so these are these questions I was going to talk about. I encourage you to just raise your hand. Those of you who are online, if you want to raise the hand emote, I believe that that is a thing to interact with this. If it's correct, please raise your hand. So what is Coriolix? I'm going to read through them, and then as I read through them, if you think it's the right answer, please raise your hand, and then we'll discuss if there are any challenges, or people have different thoughts. And here we go. Coriolix is an AI software that collects our data for us. Wonderful. Coriolix has nothing to do with AI. It's a way to see the data recently collected. Yeah, absolutely. It's a tool that can improve your science. Fantastic. It's a data archive. Kinda. It's a log for instrument maintenance and calibration. Kinda. All right. So the one that I saw that folks had a little bit on was a data archive. Seemed like everyone else got it. Everyone else had the other ones. So Coriolix does hold the data. However, after 180 days, the data moves from Coriolix to the rolling ship repository. This is where NSF standardly stores all of its data archivally. Coriolix, unfortunately, doesn't have the huge quantities of space required to do archival storage long term, so we move it to the rolling ship repository. All right, so who can use Coriolix? People on the ship? Yeah, great job, great job. Your mother-in-law? Yep, you're absolutely right. Collaborators in Greece? I think you get the trend. Now, what about a dog? Very good, very good. It was a trick question. A dog can't use a computer. A fourth grade school teacher? Yeah, wonderful. So it's everyone but the dog. Now, if you have a dog that can use a computer, in theory, they can use Coriolix. All right, so let's get into the meat and potatoes of this. Tour of Coriolix starting before your cruise. Yeah, go for it.
Like Coriolix for the ship. Available? Yeah.
Fantastic. So Coriolix is publicly available. There are a few things behind a login, and I'll go into those in a little bit, but 90% of what Coriolix does is publicly available. Once you have the link, you can use it anytime you want. There is data policy for sharing that I can go into if folks are interested a little bit later. All right, so let's jump on to the homepage. So this is what it looks like when you enter the site. And I just want to guide you around here because there's a couple key pieces of information. First, on the top right, you can see we're on the RV Savannah site. This is the only real difference between all of the Coriolix web pages. So if you were on the .sur version or server, it would say .sur up there. Next thing I want to draw your attention to is these dates and times. So that's a lot of dates and times, but they do serve different purposes. So the one at the very top is the server date time. The ones below it are the most recent ship sended data date times. So if they're not in sync, it means that the ship hasn't sent data for a minute. Well, why might that be? Well, if you look at the top, you can see the ship is within 4 kilometers of Savannah. This basically means the ship is in port. And therefore, the ship's underway system and flow-through system is off. So it's not sending any data. The last thing is feedback. Coriolix wants to support your science and research. And that means when it doesn't meet expectations or when something goes wrong, they want to hear from you about that. And feedback is really easy to give. You click on it, tell them their title, add a message of what's going on. And if you want to reply, include your email. If you don't, they get an anonymous request for something. And then over on the left, you can see there are a bunch of different ways for you to point at on the screen or highlight what the issue is. I use this all the time, or less and less, but it's really easy. And if you don't want to do that, you can always just email them at coriolixsupport@oregonstate.edu. All right. So enough about feedback. The meat of this is the data. So what kind of data do we have on here? Well, if you want a long list, you can look at the sensors. But I think that a graphical representation might be helpful here. So here's a picture of the actual flow-through system. And this is a lot, so I'm going to break it down. We've got some pretty standard pieces here. Chlorophyll, sea surface temperature, salinity. There's a nitrate sensor on here as well. And there's dissolved gases. And for those of you who like carbonate systems and the chemistry of seawater for CO2, 2 parts of the carbonate system are here. So you can solve for the rest of it with pH and dissolved CO2. There's other stuff I haven't mentioned, but we're going to move up to the top of the RV Savannah where the meteorological data gets streamed down to you. You're able to access all of the ship's data for wind speed, relative humidity, etc. on Coriolix. Now, in a coming update, and you're going to hear about this update a lot, in April, we're going to add in the CTD. This might not be immediately available, but the objective is that as the CTD profiles, you'll be able to look at this, share it with collaborators, and then hopefully even download the data straight from Coriolix. So on that, do you need an account? So there's really only 2 reasons. You want to use the PI/chief scientist tools that Coriolix has, or you want to set up an alert. All right, so what are these chief scientist tools? Well, Coriolix automatically enters every planned cruise that John enters into its server and populates a table. We can actually see Adam apparently has a cruise here in 2027. What? That's awful. I'm sorry. So in theory, your cruise, if it gets funded or if you just tell John about it, will show up here. And it'll come with some really cool tools that you can use. Nope. All right. So you'll be able to plan your cruise and select participants who are going to be part of it. You can decide your stations. There's a neat link that lets you download the data, and you can set an event log if you want to manually record, like when CTDs go in or if you're deploying other instruments. Then, oh yeah, here's how you get to that. Just the cruise toolbar. All right. I see. All right, and then what can an alert be? Well, an alert can be a change in basically any biogeochemical parameter the flow-through system measures. So chlorophyll, you might be coming in, you want to measure when we get to high chlorophyll. You can get an alert. This can be an email, a Slack message, or a text message, but sometimes those are a bit iffy at sea, so I wouldn't recommend it. The other big question that you've all heard asked at some point in your life is, are we there yet? And this can tell you when you get there, or when you get within 500 meters of there, which can be really helpful, particularly if you're trying to not ask the chief scientist or TJ for the third time if we're there yet. All right, so how do you set up these alerts? They sound pretty useful, or at least I think they are. Well, you go to your account, it's going to have this drop down, and you click on the My Alerts page. And it's going to jump you over to here. And there are some preset alerts that you can have. Some of them are like, the instrument isn't sending data. And I've got 2 of these. I get a lot of emails about the instrument not sending data, because every time the ship comes into port, the instrument stops sending data. And every time the ship turns off for a moment, or we lose internet at Skidaway, the ship stops sending data. So take these with a grain of salt, but they can be very helpful. The other one that I like is the ship here? So it tells you within 4 kilometers. So if you have to meet someone at the dock as the ship comes in, or if you just want to know that the ship has come back, it can send you that email. If you want something a little bit more personalized, you can set up a custom alert. Just fill in what you want it to tell you when the alert goes off. Make sure that you have checked the enable. It also means you can just disable it by changing the settings, and then pick what parameter you want. There's a long list, and it can be a bit challenging to page through this, but you can find chlorophyll, set it to greater than 1, and then just hit submit. And once you've hit submit, when chlorophyll is greater than 1, it'll send you an alert. So it's really easy to make an account if you want one. If these things don't sound like tools you want to use, don't make an account. It takes about a minute. You just need your name, your email, and how they should contact you. If you are saying that you're a chief scientist or PI, you may get a follow-up email, and it may take a minute to your account to get activated because they're going to give you additional privileges. But otherwise, your account will just immediately start being there. And don't forget to hit submit. All right. So another one of those questions, how can you provide feedback? You can use the feedback button on any page. Yeah. You can tell me, Ben, about your issue. Yeah. You can email Coriolix support@oregonstate.edu. Very good. Nicely done. Avoid it. This sounds too complicated. Oof. I'm pleased to see that. Messenger pigeon. What do we think? Some nods, some shakes of the head. We're unclear. We'll clarify messenger pigeon. So I encourage you to use the feedback button or email them. If you tell me, I'm going to use the feedback button to recreate the thing you told me about, or email them. And if you do want to go for messenger pigeon, they're open to it, but they're going to need a couple months to train and raise your messenger pigeon, so it may have delayed times on responses. So why make an account? Great question. You need to make an account so you can see the cruise map. Very good. If you want to do route and sample planning, you need to make an account. Okay. so your collaborators can use the site. Okay. So you can download the data. All right, to set alerts. Great job, great job. And so you know it will be for lunch. Glad I didn't catch anyone on that one. So route and sample planning, if you want to save it, you do need to have an account so it knows whose data to pull up. Otherwise, we just have random routes planned. And then if you want to know what's for lunch, ask Ben, not me, the other Ben. You'll know him on the ship. All right, so during the cruise, what can you do? Well, you probably want to know how you can access the site. Well, Morgan has set up a little station to make it easy. So the first thing you're going to have to do is you're going to have to click on this changer. And you just click the Coriolix button and it will bring you to the website. And then you're going to use the mouse to navigate the website. 90% of this requires no typing. The few bits that do require typing, you can ask Morgan and she's happy to lend a keyboard. All right, so you've gotten on the site and you're wondering that question, age old, where are we? When's the next thing? How do I find that? It's just on the home page. Well, cruise chart. And it's going to bring you over to a thing that looks like that. Now, I'm sure you can all see it, but I've added some arrows to help you find the ship. And we can zoom in and zoom out. But you may be wondering, I can see Atlanta here, the Mississippi, goes all the way up to Charleston. There's a lot of information about the land, but I'm on a boat. Doesn't seem too helpful, does it? Well, that's because this is Google Street. But if we want to, we can change our layers by clicking on this. And we've got a bunch of options. The most useful one in my mind is the bathymetric layer. And we can go to that. And there is a color bar for this. However, that's coming in April. We're working on this. Now, there's this NOAA ENC layers. Wonder what that is. Well, electronic nautical charts. These are actually really cool, and I've had a really fun time exploring them. As you zoom in and out, they change the amount and detail of information. It provides information on hazards, marine protected areas, undersea cables so you don't accidentally drop that sampler on a $12,000 wire, all the good stuff you want to know. And then you may have noticed we have some daily SST. Well, we've got satellite images that will come straight down from the server to you. And I'm going to change it back to global bathymetry as well. There we go. So this is the day previous for this cruise and what sea surface temperature looks like. Again, color bar coming soon. We know that this is an important one, but yellow and red are warmer and warmer temperatures. And we also have chlorophyll. Now, chlorophyll and sea surface temperature both need there to be no clouds, and sometimes we have clouds, but we can see high chlorophyll at the coast, low chlorophyll offshore-ish, and we can mentally interpolate a bit. Now, in a coming update, along with color bars, we're going to have the ability to pull up the underway data right underneath the map. So if you want to keep track of how a given variable is changing, you'll be able to pull that up right underneath it. We're also going to be adding a slider for the satellite data. This will let you move through the last 30 days of satellite data, and we're going to add the 8-day composites from NASA in, which really help fill out the view. It makes it a little bit less patchy than this, I promise you. All right, so now on to cruise planning. If you want a cruise plan, the little drop icon is where you're going to be able to do that. So one caveat to this, anything here, you do need an account to save it, but you don't need an account to just use it. So it'll give you the distance, and all you have to do is click once, and that's your first point, and click again, and that's your second point. And you can figure out how long it's going to take you to get there. Just change the speed from 6 to 9 knots, and we're all set for about what the RV Savannah does. And it'll estimate how long it's going to be until you get there. Sounds cool. You know where you are. You might know how long to the next station. But what does the recent data look like? That seems pretty useful. Well, we can go to here, the sensor plots. And there's a lot of them because there's a lot of sensors that get fed into this. Now, I'm going to start by exploring the flow-through plot and then the meteorological data. Feel free to explore these on your own. There's a lot of data here. One caveat, they may appear empty if the ship hasn't been out for a while. You're going to have to change the time frame for them or use the custom plot to go back in time. So just be aware as you explore by your own. But let's head to that flow-through system. So here's the flow-through page, and you can see we've got 60 minutes of data. This could be the amount of time you want, but it probably isn't. So feel free to change that. 60 minutes, maybe 60 hours of data. I would caution against 60 days of data. That's a lot of data, and it's going to take a really long time to load it once you hit the submit button. So keep it less than a week, and you'll probably be very happy with the load time. There is an update coming. This is a theme in this presentation that will help with this, but for right now, this can be very temperamental. We've also got the ability to change your axes on the fly. So if you loaded in, you noticed a cool feature, you can zoom in using the x-axis and then rescale your y-axis so you appropriately see that feature. Last little bit here, we've got these symbols on the other side. So you can change how the chart looks. You can put notes on the chart. My favorite one is the little download symbol, which lets you take a downloaded image of the graph you're currently looking at. And it'll download it straight to your computer so that you can reference it again. You don't have to refigure that out. All right.
Does that come with the data, like a CSV of the raw data that made the chart as well, or just the chart?
Just the chart, but that is an incredible idea to have it come with the CSV of the raw data. If we're, yeah. Oh, fantastic. Okay, so now we're moving on to the meteorological data. So it looks nearly the same as the flow through, except that it has the live data values on the top. Here you can see what the current or most recent reading was. These often read 0 when we're in port because the most recent reading was 0. I'm not going to go through this, but same idea. It has charts and graphs underneath it that look the same, and you can set them and see what's going on. Now for my favorite one, which is the customizable plot. This lets you pick the variables you want, the time range you want, and plot them together. So you're going to have to set this. Again, try not to pick more than 7 days of data, or else it will be a bit slow. And then you're going to want to pick what variables you want and their units. Now I'll show you a point in a moment after, and then you got to press generate. Just changing the dropdown doesn't change it. So here I've picked some units. We've got chlorophyll in counts. That's not particularly useful. I'd rather have micrograms per liter. Well, if you want to change it, just change the dropdown and hit update. But this is what our graphs currently look like. The previous ones are the updated graphs. But that just wanted to show you, this will become updated so you can zoom in, select your features, save it out in April. All right. So what if you see some weird data? What type of troubleshooting is available for you? Well, the most basic one is status. If you click on that, oh, it's a lot of red. It's a lot of sensors not working. That seems problematic. And if you mouse over, you're going to get a pop-up that says why the error is there. All right, chlorophyll hasn't sent data for 12 seconds. Well, 12 seconds for you and me, not so long. But for the internet, 12 seconds is quite a long time. That's basically, hey, it stopped talking to me. And if we look, oh, the ship's in port. That's probably why everything's red. Yeah, that makes sense. Ah, well. But if you're out there and something turns red, it will give you a mouse up for what's going on and why it's red. And then if you want, you can click in onto any given point and go to the data and information for that sensor. So here we are on the chlorophyll sensor, and there's a bunch of information here, and you can see the most recent data. So is 1.5 milligrams of chlorophyll a value that you'd expect for, say, right off the coast of Savannah? Probably. So the most recent reading was probably good, right before we came into port. But if it's showing you 10 or 20 and you're in an open ocean environment, you might know at that point that there's something weird with your fluorometer. You can do a little bit more digging if you want to and head into the actual sensor information. So this has a lot in it, and I'm not going to scroll through all of the different stuff here, but I'm just going to point out a few of the key bits of information that I find really helpful. So the first one is the actual native data format. So what this is the string of numbers and letters and words that come out of the instrument raw and how to interpret that. So the 1286, 1287, what those actually mean and how to translate it. Really helpful if you have to go back to the raw data because you might need to, say, apply a new correction. You've also got the calibration files for every instrument so you can apply that correction. This tells you how to go from that raw count to your actual units. Maintenance logs aren't currently done, but we're hoping that sometime in the future these will be implemented. And the last one that I really like is all of the tech support help. Email address to send your question to, what phone number to call. Now, I can't guarantee you that Seabird will pick up or even reply to your email, but I can tell you that the information for what email you should send it to will be there. All right. So all the sensors, what might be happening? Could the ship be not currently connected to the shore? What about data being lost? Are we losing data when it's all red? The ship is in port. Yeah? The sensors are down for maintenance? I'm on the ship. It's always going to be good. No problems. Wonderful. So the ship not being connected could happen. If for some reason Athens, where the server is currently hosted, loses power and you're trying to connect from the land side or the shore side, it might just say, hey, nothing here. We're not seeing anything. And this goes into that, is data being lost? It's not being lost if we have this. The ship will continue to record the data, and when the connection back to the shore side comes back, it will slowly backfill the data. This does take a while, but it will happen. Last one, I'm on the ship. You all seem to have gotten this idea that it might go poorly on the ship, so I won't berate this, but you can have sensors go down while you're on the ship, and it will tell you that they've gone down. All right. I want to know what temperature and chlorophyll have done in like the last 4 hours. How can I do that? I can look. Maybe I can make my own custom graph with them. Yeah. The data and plot it myself. Yep. Image that I could look at. I need to ask the marine tech for this data. Wonderful. So hopefully you can achieve looking at the data using Coriolix without asking the marine tech for the data. This is a big part of being able to put the data in your hands easier and faster. All right. Yeah. So lastly, tour is wrapping up. How do you download the data? We've all been there. We've all been looking for it after a cruise, and we're like, I wish the data was here. Well, you head to data, and there's a lot of options. So I'm going to walk you through that first one, data format, which tells you what each option does and what it gives you. Well, we've got 4 major data formats here. The first one is that raw code that comes straight off of the instrument. I don't recommend this, but it's there if you need it. The next one is the processed unit, but at raw resolution. Think of this as high resolution data. It's every data point that comes off of every instrument. There's no binning, it's just the data. And then we've got 2 different versions of bin data. These are standardly binned in a minute, but if you want, you can reach out to Coriolix well in advance, and they can bin it to some different temporal resolution, but I think most people are happy with a minute. There's 2 of these. One is statistics. This comes with the mean, mode, standard deviation, median, plus 1 quartile, minus, and then the 3rd quartile, and a handful of other things that might be helpful for you in that binning. But it's a lot of data per data point. So there's also data without statistics, and that's just the mean. I personally find this one a lot easier to work with, as I don't have to go into each cell and tell it that I want the 3rd number of each cell. It's just every cell. So let's take out a look at that data without statistics. All right, well, here's that promised 1 click, the entire data set. If you want everything at a minute binned from the entire cruise, click on the top 1-click button and it will download it. This might take a while, as downloading everything, particularly if your cruise was like 30 days long, it's going to have to put all of that into a zip file and send it to you. So you might not want everything. Well, you can use the custom data. I often do this to get rid of all of the raw values that I don't really want. So how do you do that? Well, you're going to need to go ahead and you're going to need to set your time frame. Currently the last 7 days, but I want the whole cruise. Well, go ahead and select the entire cruise. And then you'll find the cruise that is your cruise. Now, the first 4 numbers don't mean anything to us. Then you're going to have the date range, comma, the chief scientist. That's how I find here. Now, if you memorized the 4 numbers that John Bickey put on your cruise, fantastic. But otherwise, I highly recommend find the chief scientist's name or the date range that your cruise is on. And then you're going to have to pick what file format you want. And pick the one that you like, because there's a lot of options. I personally pick comma delineated basically every time. I don't know a collaborator who I can't send a comma delineated file to and they can work with it. But if you want, it can be tab delineated, it can be ready for MATLAB, it can be an ASCII file or a netcdf file. But do note that every different data source you select will create one file for that data source. All right, so there are a few things. Parameters have some overlap. So internal depth from the list has the word depth in it. Is this the depth underneath the ship right now? See Adam's shaking his head, no, it's not. There are several things that read the word depth, but aren't the actual depth under the ship. Be aware of this when you're looking for the data you want. Similarly, we've got 2 transmittances here. One's the count and one's the actual percent transmittance. I normally go through and uncheck all of the count data because I don't really want it. The last one, and this is fairly important, there's 2 temperatures that read exactly the same. One's from the oxygen optode and one's from the thermosalinograph. The oxygen optode is measuring the temperature of the water. However, the thermosalinograph is the item you want for temperature of the water, not the oxygen optode. Though I can tell you they are very close, less than 0.1 degrees C. There's just a very big difference in the accuracy. All right. But what if you want all of the data? You don't just want this minute bin stuff. You want every bump, every point that was recorded. Well, high resolution data, you're just going to have to go here and select your resolution. Now, when you're on the high resolution data page, there's actually a bit of a trap here. It looks like you can pick like binned data, every minute. This isn't actually binned data. I actually fell for this trap, and it was a pain. This is actually the data point closest to that minute or second or hour. And let me tell you, that was very frustrating to realize. So I recommend if you're looking for full resolution, just take the full resolution. Don't look for the nearest minute data point. It's not as useful as you think. All right. Adam? Yes. I'm 100% with you. Yeah, hit that feedback button. All right, and then when you're working with the high resolution data, I do recommend you pick the variables you want. Particularly if your cruise is longer than a week, these data files get really big really quickly and will take a long time to download. So a few more things. If it's grayed out, that means the instrument isn't currently active. And this is for the most recent cruise. So if you know that there was a PAR sensor in your cruise, you can click it. And if you click it and there isn't any data, it will generate a 0 kilobyte file that's empty. This can be frustrating when you realize that you've downloaded a file and it wasn't there. But if it's 0 kilobyte, that means there was no data. You probably want wind speed. I recommend true wind speed so you don't have to take the ship's movement out of it. You'll also notice there's a port and starboard. This is because there's two sensors on the Savannah. One's on the port side and one's on the starboard side. They often read just a little bit differently because there's a slight wind shielding from one side or the other. Highly recommend averaging them to get an average wind speed. Last one, there's 2 latitudes and 2 longitudes. This is because the RV Savannah has a backup GPS on it. Really important for ship safety, but really confusing when you end up with 2 of them when you download everything. I recommend picking one of the 2 sensors and sticking with that sensor. They are nearly identical to about the 6th decimal, but because they're positioned a little bit apart, there is a difference. It also allows you, if you really wanted to reconstruct the direction the ship is going, but that's neither here nor there. All right, so what are you actually going to get when you finally get an actual comma separated file? Well, you're going to get a bunch of parameters. First one is going to be the sensor ID. These are going to get updated in that April update to read more like human readable, and it will say chlorophyll. Currently, it says fluoro 82000, which is the ID that is in Coriolix. Then you're going to have 2 time columns. The first time column, raw, is the instrument time column. This is highly likely to not be accurate. The issue here is not all instruments actually have their time set by Morgan, and often they might be set in a different time zone by the manufacturer. It doesn't know this, and there's no UTC stamp on it. So use the second time column that says the actual ship time. This is the time that the ship system logged the transmission of that data point. The last 2, P3 and F3, are also going to be updated. But what this stands for is parameter 3 from the given instrument and flags 3 for that parameter. If you want to download data right now, you want to look at what the file is named to know what instrument and parameter it is. It's a fairly reasonable. This will be updated in April to be a more human readable naming system. The last one is flags. This tells you what the basic flagging has been done. And I'll get to that in a minute, but first, a brief warning. So as I mentioned earlier, this isn't an archive. We only keep data for 180 days on Coriolix. Then it moves to the rolling ship repository. This is the NSF's basic data archive. So if you want data after half a year, you can get it off the rolling ship repository. Alternatively, the chief scientist will be provided with a copy of all of the data at the end, and you can ask them. All right, briefly on flags. There's a lot of flags. There's 30 different ones. Only the first 10 are in use, and they're really basic flags. Like, hey, is the time within this century? Some of them can get tuned to be more useful, such as local or global biogeochemical parameter flags. So like, is salinity above 40? We generally don't expect that at sea. Here's a flag for it. I encourage you want to know more about the flags to check out the quality flags. But in general, I do my own quality control afterwards. These are just really basic quality control flags that you can use. All right, so before I start talking about the update in April, here's a QR code to the web page. If you want to take a shot of this and bookmark it, or if you just want to write down the actual web page so that you can access it, feel free to. So the updates. We're going to have new satellite options. These aim to expand so that there's single day for the last 30 days, the 8-day composites, sliders, and color bars. We're going to have improved binning. So we're going to move from that statistical to just the means. We're going to change backend so that all of this loads faster and is more easily accessible by users on the front end in terms of user readability. And the graphs are getting a big overhaul to be able to change axes and save out. So some last questions before I'd love to have any comments or discussion. When working with the data, I should use either time column. Fantastic. Download everything all at once. Use the feedback button if I have problems. Excellent. Make sure the data downloaded is a file type I can use. Seems pretty logical. Wait 181 days to download the data. No one? Damn. Well, you guys got it. Use the feedback button if you have issues. They're really fantastic with helping. Please note they are located in Pacific Standard Time. So if you're emailing them at 6 in the morning Eastern Standard Time, they may not get back to you for a while. And then make sure you have the right data file type. All right. How can I get help with Coriolix? Can I read the documentation on the website? Yeah. Use the feedback button and include my email. Yeah. Okay, look at this PowerPoint again. Yup, great. Email Coriolix support at Oregon State. Yep, okay. Talk with others who attended this talk. Sure, wonderful. So yeah, all of these are ways that you can get help. You can even talk to me about it, though I do recommend if you want help more quickly, the feedback button is your greatest friend. All right, last question. How do you see yourself using Coriolix? Do you want to use it to see where you are? Some of us. Route planning and sampling, perhaps? Maybe. Avoid it. Too complex. Just walk away now. Sharing data with collaborators? You had an idea that wasn't listed here. So I'm hoping that all of you were thinking any of these except for C. And I'd love to invite anyone who had an idea that wasn't listed here to share that. And if you have any discussion, questions, or stuff, I'm happy to take them now. And the QR code goes to the website. Thank you.
questions? Athens or online students? You've done a great job. Ellie?
Standard operation. Is there a calibration often? And this is interested in my I don't use it very often. I use it to do one time relay for auto analyzers, and it might be really when our enters nitrate less than 0.5 seconds on it. This is something that year end, how comfortable are you with some of the sensors and like using
Okay, so a couple questions. I'm going to repeat them a little bit for folks online. Sensors, do they drift? What's the calibration like? So NSF for the standard instruments can have funding to calibrate them once a year. Currently, there may be less funding. And part of that I actually would encourage, if you're using Coriolix or any of the instruments, please add in the acknowledgments that this was helpful for you so that we have a place to point to for NSF to tell them that we need to keep these calibrated and well maintained, as it does cost a substantial amount of money to keep that entire wall in calibration. So currently, annually, they get calibrated, and then Morgan normally maintains them to remove any biofouling at the beginning and ending/end of every cruise. This does take quite a lift from her. So if there's a sensor that you're particularly interested in, you want to make sure, I would reach out to her in advance. Now, is there a, ooh, it's drifting automatic? Currently, no. This could be implemented, but it's very challenging to implement because you could just be moving from low concentration to high concentration of chlorophyll over like a 3-day period. And so that could flag it. That would be more of a, you look at the data and see a trend. The only time I have ever seen true biofouling was the month-long cruise from here down to the Gulf of Mexico, in the Gulf of Mexico for 2 weeks and then back up, where the total dissolved gas sensor just kind of did this for a month, which was really unfortunate. But in theory, we could set up flagging for, hey, it's outside of reasonably acceptable limits for any of these, and you could get an email for that. And the last question was on the nitrate sensor. So we actually learned a lot about the nitrate sensor because it is temperamental. And the big challenge with the nitrate sensor is it uses UV in order to estimate nitrate. So if you have a lot of particles in the water that absorb or emit UV when you shine our light on it, because it's fluorescence based, it's going to mask the signal. So in turbid waters, like around here, we actually end up with the nitrate signal reading NaN until we get towards much more open ocean waters. And the issue with that is that there's so much sediment in the water that our fluorescence is just completely masked. I'm happy to go into this in more detail if you would like, but yeah, nitrate is touchy.
So we haven't been using it a lot. We mostly treat it off and but if you're interested, you can figure it out. And you can send them around so that every time
Anyone catch it? Oh, Tristan's one of the folks who does this. Hey, Tristan. I'm not sure if we can get you unmuted so that you can make the comment, but We saw it, but I couldn't read it, and I don't actually have access to the text channel, unfortunately.
Oh, hey everybody, hey everyone. Not sure if you can hear me. Just wanted to say thanks for the presentation, Ben. We're super grateful to be collaborators and look forward to some feedback.
Oh, really glad. Thank you. Wonderful the entire time. They really are fantastic folks to work with. If not, thank you all for attending. I really hope you learned something and find this useful going forward. Cheers.